Oh, I know. And somebody wanted live transcript. Okay. I believe that each one of you can turn off the closed captioning down at the bottom of the screen if you want to. Okay. But somebody last night requested it, and it's okay with me. Okay. A couple things. We'll get going on this. Um, Attendance is important, guys. You need to be here for the entire class time. So make sure you are, um, because several people were actually here a lot of the class, but weren't here when I took roll, and that kind of screws you over. The next thing I want to talk about is um, throughout this semester, you're going to have to be able to scan something on from your phone, or a couple of you said you had actually a scanner. You had your HP scanner. Okay. And it has to be in PDF format. Now, there's a reason for that, but I'm not going to go through the reasoning today. I'm just going to say you have to be able to scan as PDF. Okay. It's a special type of file. There's something called CAM scanner. Okay. It's a free app. You shouldn't have to pay a dime. Not a dime. They'll try and get money from you. Upgrade and all that. Nah, screw it. You don't need it. There's also something called Genius Scanner. Okay. And what these do is these take a picture of whatever you've made here. Happy face, curly hair, whatever. And they save your picture on your phone into what's called PDF format. It's a special format. Most of you are used to JPEG. Okay, that's for pictures. Well, PDF is like JPEG but different. Okay, needs to be in PDF. Cam Scanner will do it. Genius will do it. There's other scanners that will do it on your phone. And what it does is it takes your camera, takes a picture, but then converts it. And then what you need to do is simply email it to yourself so you can then upload it to whatever device we're going to use. Okay? And in this case, we have this mom quiz. It's either Sunday or Monday. I'm going to say this weekend. Problem number 11 asks you to add work. It asks for what's the answer to the question. Say, what's the answer? And then there's a little button under there that says add work. That's where you're going to just upload a picture of your work. A picture of your work that you took it from your phone or your scanner, the HP scanner. That's the easiest way to do everything. If you have an all-in-one scanner, scanner, printer, fax, that kind of crud. If you have that at home, that's awesome. Okay, but this is just as easy. Okay, you take a picture of it using that cam scanner or Genius, email it to yourself, and then put it into there. Just drag it into there. Browse, grab it, put it into there. You're done. The reason I'm asking you to do that, okay, is twofold. Number one, I do want to see your work throughout the semester. Okay? You can't just turn in an answer because I need to see, are you using the proper steps? Are you using the proper logic? What are you doing? So throughout the semester, I just need to see your work. Secondly, there is a good possibility, a very good possibility that this Delta virus is going to get out of control, and the school is going to say, you know what, we're going remote all the time. Nobody comes on campus anymore. If that's the case, then then you people will have to scan everything to me. All of our tests, you're going to have to scan them and send them to me because I have no way of getting them back from you. So this is a little exercise in practice. How to scan something, how to upload it into Mom, or next week I'm going to have you scan something and upload it into Canvas. But right now, just to keep things from getting complicated, I want you to be able to scan something, okay, upload it, okay, into your phone or whatever, email it to yourself, and then from there you can put it into your quiz, number 11 on the quiz. Next week we'll have another exercise. Okay, let me show you something on Canvas. Okay, on Canvas, am I on Canvas for everybody?
Yeah.
Yes.
Yes.
Yeah, okay, cool.
Yep.
Okay, if we go to modules, okay, and okay, wait a minute. I'm gonna go to student view. If we go to Canvas, go to modules, go to resources, come on. And again, this is how to enroll in Mom and get started. This, however, talks about using Cam Scanner, but all the scanners that you're going to find, Genius Scanner, they all follow pretty much the same steps. But here I have a step-by-step document, and then it actually accesses within the document a video that I found by some woman who it was a really good job on how to use Cam Scanner to make a PDF document. What? Okay. Crap. Okay. Here's a tip. Okay. I have a Dell laptop. It is wonderful. Okay, one of the best computers I've ever had, except that the touchpad, okay, is so sensitive. If you breathe on it wrong, it goes someplace. It does something. Okay, and I have been complaining to Dell. You know, they keep sending me, okay, get this driver, do this, do your settings here. Nothing works. The touchpad is super sensitive. Okay, that's the only complaint I have about this computer. Otherwise, it is a great little computer. Okay, so anyway, that's my bad thing about Dell. But down here, this talks about using Cam Scanner to make a PDF document. Okay, and so you can look at that and practice on that. It's pretty simple. The other thing you can do is go onto YouTube or just go onto Google and say, use Genius Scanner. Okay, and you'll find all kinds of people have put up help videos on Google, on YouTube to show you how to use a different scanner. Now I want to go back to my home page. Okay, I'm going to scroll down. Boom, 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 boom. Okay. For the assignment coming up next week, I put these notes here, but I talk about using Cam Scanner, something called PDF Scanner, Fast Scanner, or Genius Scanner. Genius. Okay. These are all ones that students from my past classes have said are easy to use. They like them. They're easy to use. So you can search for them on your app store for your particular phone, download them, give them a try. Okay, but they all should be free. Don't let anybody force you to pay a dime. Okay, so play with that. Try and play with that between today and tomorrow so you can come back and maybe we can help each other work on that before the weekend because you want to kind of get that done. Um, Here's the next thing I want to show you, still on Canvas. Let's go to modules again. Okay, close that. Okay. Yesterday we started lecturing. Okay, a whole bunch of junk about all kinds of stuff. It was kind of boring. So in one way, I understand why some people may have left. But I taped us. Okay, and I put this here. This is a video. It goes to my YouTube site and is a complete video of everything I talked about last night. Okay, including my bad jokes, including where I forgot to turn the video off, so there's like sometimes 10 minutes of dead time. We took a break in the middle of class, like an idiot. I forgot to turn the video off. So there's what, 3, 4, 5 minutes of just dead time. Anyway, I'll be better tonight. So anyway, this is how I'm going to put it up every single night. I'm taping us, okay, and then I'll put up a video of the previous day's lesson here. Okay, I'll tell you what it was, week 1, day 1, and I'll give you a little bit of description of what we covered. Okay, and I'll also put the date here. And I will do this for every single lesson that we have. Every single lesson. Okay, I will tape it, record it, and make it available to you. Okay, so use that to your advantage. Okay. So, with that, boom, 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 boom. Why collapse all? Home. Let's go home. There we go. Oh, there it is. Sorry. Leave student view. Bingo. Okay. I want to do some math, get into math stuff, a lot more math stuff tonight. Does anybody have any questions? Why isn't this big? Boom. Does anybody have any questions about anything I've said or done so far before I just start doing math?
Did you take roll already?
Pardon me?
Did you take roll already?
No. And I won't use last night's code tonight. It'll be different. You got to hang around and find out what's there. Surprise! Anybody else? No, I take roll at weird times. Okay, sometimes in the middle, sometimes at the end of class. Sometimes I just don't take roll at all, and then everybody's pissed at me. Oh, there's my dog. Okay, so here we go. If you have questions, interrupt, always ask me. Come on. Boom. Okay. Okay. Yesterday, I introduced something for what was called inequalities. Okay, an inequality is anything with a less than, a greater than, or less than equal, greater than equal. Those are all inequalities. And I talked about the two formats. And I called this the old traditional. Things like x is less than 5. Okay? That was the old traditional way of writing things. And then I talked about a new method called interval notation. And this is the new modern way of describing things. So what interval notation is a description of what you would graph. If you had to graph x is less than 5, okay, you would have 0, you'd put 5 out here on the number line somewhere, okay, and then you would put an open circle on the 5, because less than means can't equal, and then you would shade this way, okay? So interval notation describes what you've just put on the graph. So we would say for interval notation, what has been shaded is from negative infinity up to 5, parenthesis. Okay? Traditional notation, interval notation, graph. You're responsible to be able to do all of those. If this is traditional, you have to know how to graph it and have to write it as interval notation. If we have something in interval notation, you've got to be able to interpret that, be able to graph it, and then write it the old way. Okay, and on that mom practice quiz, okay, there's a couple problems like that. And obviously we'll be doing more throughout the semester. Okay, couple questions, really important. Why did I use parentheses here? Parentheses mean you're approaching that number but never reaching it. For example, you can never reach infinity, negative or positive, it doesn't matter. You can't reach it. So anytime you write an infinity, it will always have a parenthesis because you can't make it to infinity. Now this one, we can't make it to 5. We're going to come up really close to 5, but never get to 5, ever. Okay, because of that open circle, because of that. Okay, so that's why the parentheses. The parentheses mean we're not going to get there. Okay, the alternate way is a different example. What if we had x is greater than or equal to negative 2? X is greater than or equal to negative 2. Well, the graph of that, here's 0 again, here's negative 2. Notice I'm not real big on the scale. 0's nice to know because everything centers around 0, and negative 2. You don't have to show me negative 1, positive 1. You don't have to show me all that crud. I don't care. Just show me the key values. 0 is an important one. It shows me where the center of everybody is. Negative 2. Okay? Now, this time, because it's greater than or equal to, we use a solid dot, and greater than means we shade this way. So that's the traditional way of saying x is greater than or equal to negative 2. That's its graph. Okay? The interval notation for that is, okay, bracket negative 2, comma, infinity, parenthesis. Again, by the way, the infinity is implied to be a plus infinity. Just like for positive and negative numbers, we have to write the negative on a negative number, but we don't have to write the positive. Okay, but whatever. So anyway, again, when you're going to infinity, you can never reach infinity, ever. You can't make it to infinity, despite Buzz Lightyear. So infinity always has a parenthesis next to it. Okay? In this case, we will make it to negative 2 because it says we can equal negative 2. That's what that says. That's why we had the solid dot. So these are the two basic ones right here. And then I threw at you, okay, something like -7 is less than x, which is less than or equal to 21, or something like that. Okay, so I told you that this is simply x is everything in between -7 and 21. Again, I recognize that right now most people don't understand that. Okay. Actually, that's one of the reasons why interval notation was invented, because students didn't understand what that meant. Okay, so they invented another notation. Again, x is everywhere in between, so we're going to shade all of this in between. Now the question is, we're not going to equal 7 because there's no equal sign there. X does not equal -7. But it does equal 21 because of the equal sign there. So in interval notation, okay, this would be parentheses -7, comma 21, bracket. And that's a pretty concise review of what we talked about last night. Now I want to add to this, but does anybody have a question about this before we go on? Okay. Again, I think there's one or two questions on the practice exam about this kind of crud. We will get into this in much more detail throughout the semester. So we're just kind of introducing it. And this is probably new for 90% of you. Almost everybody's seen the x is less than. Almost nobody has ever seen the interval notation before. That's pretty new. All right. Now, a couple of things. First off, I call this the old traditional. It actually has a name. The name, its official name, is called Set Builder Notation. Set Builder Notation. Okay? And there's entire courses devoted to why and how you use this notation. Okay, the concept of a set is a fundamental concept in higher level mathematics. The concept of a set is big time mathematics. Okay, so you're going to see in the homework, it won't say use the old traditional way. It may say use set builder notation. Well, that means the old traditional way. Or the homework may say use interval notation, which means that. Now, there's one last thing that I have to show you up here. What if you had this graph? I don't know. Let's see. -5, 2, open circle, closed, like that, and 10, open circle, shade, arrow. Now I just made this up. We'll see what happens. So what if this was a graph that you had for some reason? Okay, open circle on -5, okay, shaded in between, solid circle on 2, then jump, open circle on 10, shading forever. Okay, I'm going to show you this and then we'll work on a different one. Okay, how do you write this in interval notation? How do you express this picture using the new modern interval notation? Well, this one's easy. This is parentheses -5, comma 2, bracket. That's what that says. Interval notation, remember, is just a description of what's on the number line. That's all it is. Out here, parentheses 10, comma, infinity. Okay? But how do we say that these two separate parts of the graph are part of one big answer? So we introduce a new symbol in math. It's an up U. It's a capital U. Okay? And it means in math, we'd say it's the union. Hence, that's why it's a capital U. And it means all together. Okay? All together. So it means, all right, we got this chunk of the number line, and we got this chunk of the number line, but the union means they're all together the answer. So that's what that new symbol means. A capital U is the word union in mathematics. Okay, and it means all together, totally combined. So let's try this one. Shade, 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 shade. Negative 21. Closed circle there. 3, 5, closed, closed, shaded in between. Anybody want to take a shot? What do you think?
I got an answer.
Go ahead.
Parenthesis, infinity, comma, negative 21, bracket, the U symbol,
Big U, union. Okay.
bracket, 3, comma, 5, bracket.
Okay. Except for one tiny thing that's 100% correct. So let's call it
infinity, yeah.
Infinity.
Yeah. Negative infinity. That's perfect. Is that okay with everybody or not? Any questions on that? No?
I have a question that like for future exercises, are we using the other form too or only
This
that?
one?
Yeah.
Yes, and that will depend completely on what the directions say.
Oh, okay.
Sometimes the directions will say, use set builder. Sometimes it'll be multiple choice and your only answers are those. So you go, oh, they want me to use set builder notation. Other times the directions will say use interval notation. So you have to read the directions and just kind of do what it says.
Okay, thank you.
Sure. Anybody else? Okay.
Actually, yeah, Professor, can you do that in set builder notation right now for the last problem you did?
Yes. Okay. In set builder, it would be x is less than or equal to negative 21 or, okay, 3 is less than or equal to x, which is less than or equal to 5. So the union symbol, the U, becomes the or in set builder. I'm not going to expect you to do this. Don't panic on that. I'm going to expect you, if I gave you a graph like this, could you put it in interval notation? I'm not going to expect you to go back that. I mean, that's getting into the deep end, and I'm trying to keep this as simple as we can. But that's the correct answer. X is less than or equal to negative 21. That's that one. And then X is between negative 3 and 5. That's that one. It's got equals there because those are solid dots. and we say the word or. Some books put a comma there instead of the word or. I don't like that. Okay, and most instructors will either say or put the union there, not the comma. But that's good enough. Is that okay?
Thank you.
Yep. Anybody else? Okay. Let's see. One of the things we also talked about last night was PEMDAS. Okay, order of operation. Okay, and the P, I said most people think it means inside parentheses, and that's technically wrong. It should be inside any grouping symbol. Now, parentheses is our most common grouping symbol. When we want to group a bunch of things together, most of the time we use parentheses. But there are other grouping symbols besides the parentheses. Brackets. We sometimes use brackets. So you may see something like 5 plus 2 bracket 7 minus 4 parentheses 2 minus 9 close close. You might see something like that. Don't worry about it, okay? I'm not going to go through this one right now. But these are grouping symbols. So parentheses, this. But the grouping symbol I want to talk about is the fraction bar. The fraction bar is also a grouping symbol. It separates the numerator from the denominator. So what you want to do is you want to you want to think of the numerator as one problem. Get an answer for it. And then you want to think of the denominator as another problem. So you want to clean up the numerator and the denominator separate from each other, because the fraction bar is literally separating them until you've simplified them as much as you possibly can. After you've cleaned them all up into one thing, then you say, maybe I can reduce, maybe I can't. I don't know. Simplify, reduce. Let me show you what I'm talking about. Suppose you had 5 plus 2 parentheses 6 minus 8 over 5 plus 3 to the second power. Okay? The temptation for students is to go, oh man, I can cancel those 5s. No, you can't. Because the fraction bar literally is separating the numerator from the denominator. So you need to get one big fat answer for the numerator, one answer for the numerator, one answer for the denominator, and then see what happens. So your work might look something like this: 5 plus 2 parentheses negative 2 over 5 plus 9. 6 take away 8 is negative 2. Now, according to PEMDAS, we multiply, so the top is 5 plus negative 4. 2 times negative 2 is negative 4. On bottom, 5 plus 9 is 14. Okay, on top, keep going. 5 plus negative 4 is 1. The bottom stays 14. Okay, And so there's our answer, but the question is, does it reduce? Can I reduce this fraction any more? Okay, I don't think so, so there's our answer. Notice the proper way to do some of this arithmetic is always working down the page. Okay? Most, not all, but most of the world follows this pattern that here's our problem. The first step we do is under it. Next step, next step, next step, next step. Okay? How can I put this in a professional way? It generally pisses off instructors from Western cultures, check my words, when people do a problem sideways. Let me show you what I mean. Suppose you had 5 squared minus 7 times 6 minus 4 squared, something like that. People write, this is 25 minus 7 times 2 squared, going sideways, equals 25 minus 7 times 4 equals 25 minus 28 equals negative 3. 90% of all of your instructors will hate this, and they'll write nasty messages to you. If you've been taught this way, go back and check with your instructors. They never used an equal sign, and if they did, they were wrong. What they should be putting here is a double arrow saying this step is equivalent to this step, and this step is equivalent to this step, and equivalent here, double arrow, double arrow. It got kind of screwy in here. The equal sign, if you're going sideways, the equal sign is wrong. You should be using an arrow to say this is equivalent to this is equivalent to this, and so on through. It's much preferred that all your work flows down the page if you possibly can. Okay? I know some of you were taught differently, slightly. I'm trying to show you what other instructors at Mesa will expect you to use. Anyway, my point was PEMDAS. Okay? You got to separate the numerator from the denominator, get a clean answer on top, a clean answer on bottom, and then ask yourself, is there any canceling or reducing? But you can't cancel right away. You cannot do that. Okay? Next thing, and we kind of did this before class, but I want to do it again because it's important. What was that problem? Oh, you had this. You had b squared minus 4ac, and somewhere it said b was, I don't know, negative 2, c was, a was, come on, dummy, a was 5, and c is negative 3, something like that. I don't know. Somebody asked me this question before class started. It was similar to this. Okay? This is super important, guys. Super duper. Okay? First off, most of you know that this is asking you to substitute these numbers in place of ABC. So, this would be negative 2 squared minus 4 times 5 times negative 3. And what I've just written up here is 100% wrong. Okay? 100% wrong. You've just screwed up the problem. In fact, if you go to your calculator and you go -2, and then on your calculator, some of you can use that button for squared. -2 squared, your calculator will tell you -4. Okay, and that's wrong. Okay, I can't stress this enough. What we're saying here, when we wrote b to the second power, we meant all of b to the second power. There was an implied parenthesis here to say all of b is being raised to the second power. Okay, when you wrote, well, I'll come back to it. And to be really honest, these should have been in parentheses. We really don't like the little dot symbol for multiplication. So now, -2 to the second power, quantity to the second power, means -2 times -2, which is +4. Negative times negative is a positive. 2 times 2 is 4. So this becomes a +4. Okay? Minus, all right, technically we're supposed to go from left to right, so this is 20 times -3. 4 times 5 is 20, left to right. So this is 4 minus 20 times -3 is -60. 20 times -3. Remember, Pemdas says you got to do all that multiplication before you do the subtraction. All right, so now we have 4 minus a -60. Okay, and most of you have learned that minus minus turns into a plus, so 4 plus 60 is 64. Okay, and that's the answer. And there's some homework in chapter 1 that covers this kind of problem, where you plug in these numbers and then do the arithmetic. The point of all of this that I'm trying to make is these two numbers, -2 squared and -2 squared, are not the same. Now, if you were only listening to me, you would have said, huh? What's he talking about? -2 squared, -2 squared. But look at the parentheses. Okay, look at the parentheses. Okay, on this one, all of the -2 is being squared. So this one over here means -2 times -2, which is +4. This one is trickier. It technically means -1 times 2 times 2. The negative here stands for a -1. -1. Notice in this problem here, okay, look where I'm pointing, only the 2 is being raised to the second power. Only the 2 is being raised to the second power. Whereas in this problem here, the 2 and the negative were both being raised to the second power. We get a different answer every single time. This turned out to be -4. Okay, my point is use parentheses wherever you can, including your calculator. Most scientific calculators have a parenthesis button. Use it. When it talks about b squared, be sure and put it in parentheses. Okay, enough of that. Moving on. Okay, we have the concept of absolute value. Absolute value. And technically, although not too many people remember this, this is the distance from 0. That's the official definition, although most people don't use it or understand what it means. The key here is that the distance you travel is always positive. I don't know how many of you guys run, jog, or hike, but think of this at the end of the day. If you hike 5 miles this way, or you hike 5 miles this way, haven't you traveled 5 miles? Don't your feet, or let's make it 15, just to be weird, just to be really painful. Doesn't your feet and your back hurt whether you went 15 miles to the north or 15 miles to the south? Distance always represents a positive value. Okay, your car doesn't matter whether you go 15 that way or 15 that way, it still burns gas. Distance is positive. Well, what's this got to do with anything? Well, for example, the absolute value of -3 is literally asking how far from 0 is -3? How far would you have to walk to get back to 0? Well, you'd have to walk 3 miles or 3 whatevers. So the answer is 3. Okay? Absolute value of +7. Okay? Again, you're at 7. How far would you have to walk to get back to 0? You'd still have to walk 7 miles. So the answer is 7. So what most students remember is the answer to an absolute value problem, the answer is always positive. Whether the inside number was positive or negative doesn't matter. The answer is always positive. That's what most students remember. The answer to an absolute value problem is always positive. Well, we can't leave it there. We got to make life ugly for you guys. Absolute value is like a super parenthesis or grouping symbol. It's like a super grouping symbol. Let me show you what I'm talking about. 5 parentheses 2 times 6 minus 15. Okay? The absolute value is a grouping symbol. You have to do inside the absolute value, inside the grouping symbol, first. But inside, I have an option. What do I do first? Do I multiply or do I subtract? See, that's the question you ask yourself. Okay, I got to do inside. I got to go inside. I got to go inside. But what do I do inside first? Do I multiply? Do I subtract? Well, I multiply. So a next step might look like this. Okay, 6 times 2 is 12. 12 minus 15, whoops, this is 5, absolute value of -3. The only time you drop the absolute value is when you have a single number inside, a single expression inside. That's the only time you can drop. You can't drop the absolute value here because you got a bunch of crud inside. You can't drop the absolute value here because you got a bunch of crud inside. Only when you simplify the absolute value down to a single number, now you can decide to drop it. So, what's the absolute value of -3? +3. So this becomes 5 times +3. Okay, final answer, 15. Okay, couple things here. I may make a big deal about it. First off, you can't drop the absolute value symbols until you have a single number inside the absolute value. until you've simplified everybody down to a single thing. That's rule number one. You can't drop the absolute value until you have a single thing inside. Then you drop it and make it positive. Next thing, okay, you can never distribute into the absolute value. I know some of you have learned the distributive property. You've been taught, like 3 times 2x plus 5. Okay, you've been taught to go 3 times 2x is 6x, 3 times 5 is 15. That's called the distributive property. And I know you guys have been taught that. But notice the difference. Those are parentheses. These are absolute values. Okay? You can distribute across a parenthesis like I did here. You cannot distribute across an absolute value. Okay? Actually, I lied to you. 50% of the time you can and get it right. 50% of the time you can't. You'll get it wrong. It's safer for me as an instructor to say, just don't. Don't distribute into an absolute value. It's safer. 50% of the time you can. But 50% of the time you'll also get screwed up. So it's safer to say, just don't. Don't distribute into the absolute value. Okay? Let me show you an example that might do that. -3, absolute value, 6 minus, 9. We'll make it real simple. Okay? Go ahead. That should be about a piece of cake problem for everybody. So if we did this the right way, do inside, 6 take away 9 is -3. The absolute value of -3 is +3, so 3 times regular 3. Final answer, yeah, still there, is -9. Okay, what if we had done the same problem, okay, -3, absolute value 6 minus 9, but we distributed inside. Okay, -3 times 6 is -18, -3 times 9 is +27. 3 times 6 is 18, negative. Negative times negative is +27, absolute value. Clean this up, this is absolute value of 9. Okay, this is 9. The absolute value of 9 is 9. Notice similar answers, but totally different answers. One was 9, one was -9. The only one that's right is the -9. You can't distribute into an absolute values group, okay, safely all the time. You'll get screwed up. So this is 100% wrong right here. Okay, so my answer is just don't. All right, I got a few more things to talk about, then we'll take a quickie break for a few minutes. Any questions so far about whatever I've covered or whatever I've been saying? Any questions at all from anybody? Hang with me for a few more minutes. We'll take a break. Okay. No questions. I didn't hear anybody yelling. So, does it say we're recording? You are whatever. I think it says we're recording. I don't know. I hope we are. All right. Next thing I want to talk about is something, again, some of you have seen, some of you should have seen it, but forgot it. And it's the concept of a function. Now, we're going to revise this. I'm going to give you tonight just a real simple definition of what a function is in math. But as we go throughout the semester, I will change this definition. I will make it more complex. I will make it more useful. As you move into higher levels of math, the concept of a function becomes much more important than an equation or than an expression and all that other crud that we worry about in algebra and pre-algebra. A function becomes the center idea of a whole bunch of higher level math. But tonight, okay, we're going to start with simple. A function is a rule that changes the value of an input number. So some of you have seen something like this. This is introduced as something called, maybe you've seen something known as a function machine. And you put something in, comes in here, and something comes out. This is how a lot of instructors identify a function machine. Okay? And the rule is whatever you put in, you go, for example, 3 times whatever you put in, whatever that is, and then you add 5, and then you square it. Okay? So this might be, in words, what your rule is. I just made this up, guys. It'll be different every time. Okay? But, so let's suppose we put in, here's our in, and let's say we put in a 5. 5 goes in. According to this rule, we go 3 times what we put in. So 3 times 5 is 15. Then we add 5 to it and get 20. And then we square it. Okay, and out comes 400. So 5 got changed into 400 according to this rule, this function rule. Okay? And again, this little function machine, function box, this is the way a lot of instructors introduce the concept of a function. Somebody goes in, it gets changed according to some math formulas, and then it comes out as a different number. Well, mathematicians look at this and go, okay, way too slow, way too clumsy, too many words. So they invented a notation, and sometimes I think they invented it on purpose just to screw up students. Okay, they invented this notation called function notation, and it looks like this. Okay, I just made this up. First off, you read this as f of x. It's not f times x. It's f of x. And that's going to be hard because you have to learn to read in context. You kind of read, okay, what's this kind of mean? It looks like an equation, but it's not. It's a function. Now, what this also means is f of n equals n squared plus 3 times n plus 1. X simply stands for what you plugged in, what you started with. X is what goes in. So when we write f of x is x squared, we say what you put in, we're going to square it. We're going to multiply it by 3. Oops, we're going to subtract 1, sorry. And we're going to shove all that together, and that's my answer. So let me give you, what am I saying? Suppose I said I want you to find, whoops, or evaluate f of negative 2. So you're putting negative 2 in place of x. So you have negative 2 squared, because you're putting negative 2 in place of the x. Negative 2 is going in for the x, plus 3 times negative 2 minus 1. Now just work out the arithmetic. Negative 2 squared is 4, plus negative 6 minus 1. 4 plus negative 6 is negative 2 minus 1. Final answer, negative 3. So according to this function that I just made up, okay, negative 2 got turned into a negative 3. A function is a rule that changes the value of an input number. So negative 2 got changed into a negative 3. So using this same function, let me go back. Let me hesitate. The f here is meaningless. Well, not quite. It's meaningless. That's just its name. Like my name is Larry. This is the name of this function is f. Okay? What does f do? F takes whatever you give me for input and squares it, multiplies it by 3, subtracts 1. Okay? F is just simply its name. Nothing else. The F has nothing to do with it. My name is Larry. What do? I talk all night. That's my function. Talk and talk and talk. What's F's function? What's the rules function? To do this math. Now we can make up another one. We like to use G. G of X. I'm just making this one up. Let's say it's there's the G function. 3x plus 1, fraction bar, x squared. Okay, so G of X is this mess. I want you to find G of 5. Take a second, work that one out. Okay, so this is actually saying put 5 in place of X in this rule. So you would say, oh, this is 3 times 5, because X is 5, plus 1 on top, and on bottom we have 5 to the second power. Now all we're doing is Pemdas. That's the only thing we're doing, just doing the arithmetic. 3 times 5 is 15, plus 1 over 25. Have to clean up the top. 15 plus 1 is 16 over 25. Remember, you can't cross-cancel the 15 and 25, because the fraction bar says keep the top and bottom separate until you have a single number on top, a single number on bottom. Then ask yourself, does 16 over 25 reduce in any way? Don't think so, so that's my answer. Now, this is the answer. If you saw this on Mom or you saw this on a test, this is what you would write down and you'd be done. 16 over 25. Okay, we know that 5 got turned into 16 over 25 according to this rule. Okay, it means this, but nobody ever writes this. It means 5 got turned into 16 over 25. But nobody ever writes this. They just do this work, circle the answer, and we look at your work and then we say, oh, that means 5 got turned into 16 over 25. We don't write this. We don't write this, just this. Okay, that's the concept of a function. Any questions on function? Anything? Let's take about a 3-minute break and come back and we'll start chapter 2. All right. So actually I lied. There's a couple things I forgot that we wanted to cover in chapter 1. Okay. A couple things. Chapter 1 still. Everything I've been talking about is either going to be on that practice quiz or chapter 1. Up to now, everything is either on the practice quiz or chapter 1. Okay. Still in chapter 1, we need some vocabulary. And the first vocabulary word is an integer. An integer is positive and negative whole numbers. And 0. And it goes on forever. Those are integers, positive, negative integers. Notice an integer has no fractions and no decimals. So an integer is positive and negative whole numbers or natural numbers. Okay? And 0, they include 0. No fractions, no decimals. Now, something called a rational number. A rational number. Okay. Think about this for a second. The root word of rational, can you guys see the orange? Does it show up or not? Okay, kind of does. I'm going to go to school, I think, tomorrow and get some red. Make sure it shows up. Is a ratio, and a ratio is a fraction. So a rational number is a fraction where the top is an integer and the bottom is an integer. What do you want? No, 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 no. Sorry, I'm teaching math. I'm not playing with dogs. Go away. No. Okay. So a rational number is a fraction because ratio means fraction where the top and bottom are both integers. So, for example, you could have 5 over 3. That would be called a rational number. You could have negative 2. Huh? Because negative 2 could be negative 2 over 1. So negative 2 is a rational number. Okay, because the top is an integer, the bottom is an integer. These are all examples of rational numbers. We could have 3 over 4 because the top is an integer and the bottom is an integer. These are all examples of what we call rational numbers. And the key here is their decimal. If you pop all these into the calculator, is either one of two things. It either terminates or it repeats a pattern. So, for example, 3/4, if you turn that into a decimal, it would be 0.75, and that's the end of it. That's called a terminating decimal. It stopped. Okay? 2, or negative 2, I don't care, is 2.0 whatever. Its decimal stopped. Terminating. Now, 5/3 is a little trickier. It's 1 2/3. Remember last night we talked about mixed numbers and improper fractions and that kind of crud. But if you turn this into a decimal, this is 1.66666 forever. And how do we write, what's the math way of writing an infinite number of sixes? Isn't it 1.6 and then we put a bar over the part of it that repeats? Okay, so these are all called rational numbers. Okay, they can be expressed in two different ways. Either they're an integer divided by an integer, like these, or if we look at a rational number in its decimal form. Okay, the decimal either terminates, like 3/4 terminates as 0.75, or it repeats a pattern. Okay, now that repeating a pattern is kind of important. So these are rational numbers. Then there are things called irrational numbers. Irrational, meaning literally not rational. Not rational. That means they cannot be, they can't be an integer divided by an integer. They can't, because a rational is an integer divided by an integer. Okay, so it can't be this. That's an irrational. An irrational also has an infinite decimal with no pattern. Okay, two things, just exactly the opposite. A rational number, its decimal stopped sometimes. Okay, or if it didn't stop, it had a pattern. This is saying if it's irrational, its decimal will go forever and ever and ever and ever, and there will be no pattern to it. Now, probably the most famous irrational number is pi. Okay, now we all know more or less that pi is 3.14. Well, that's a lie. That's just us being lazy. Okay, we should write, although I'm not going to take off for it, we should say pi is approximately 3.14. And anybody have their calculator? And you punch in pi on your calculator? There's a mine. Ah, crud. Crud. Yeah, my calculator, I gotta trick it. It won't do it. It actually goes 3.141597, so on, so on, so on. And for God knows why, in some countries they have contests. Well, in the United States we have it too. Okay, for the Sheldons of the world that can memorize pi out to thousands of decimal places. They have contests to see who can have memorized pi out to 1,000, 2,000, 5,000 decimal places. For the life of me, I can't figure out why that's important, but it is. The key thing here is pi is called an irrational number. Okay, its decimal goes forever. It's an infinite decimal going forever, and there is no pattern here at all. No pattern. Okay, there's another number. Some of you who've taken Math 96 before, E, you might have seen it. E is a number, 2.78, and then it goes on, and I got to look in my calculator to figure out what it is. Okay, but that's another irrational number. It goes on and on and on and on and on and on. But there's billions of irrational number. every square root that doesn't work out nice. For example, the square root, over here of 16 works out nice to be 4, and 4 can be expressed as 4 over 1. So the square root of 16 is a rational number, because eventually when you simplify it, it becomes an integer divided by an integer. But any other ugly square root, the square root of 3, I don't know what it is. It's ugly. It goes on forever and ever and ever. Okay, you can look it up on your calculator or whatever you want, but it goes forever. The square root of 5, the square root of 6, the square root of 8. Okay, the square root of 72. Any square root that doesn't work out to be a nice, pretty number is called an irrational. Okay, it's called an irrational number. So we're almost done with this discussion, but math is real big on categorizing numbers. Okay, I didn't do it here, but we have something called the natural numbers. The natural numbers are what a baby learns. 1, 2, that's the natural things, 3. And then we introduce the concept of 0. And then we introduce positives and negatives. So math has this really neat way of organizing groups of numbers. Okay, the two big groups are rational and irrational, and they're identified by mostly by their decimal. Either it goes on forever with no pattern, or it has a pattern, or it stops. Okay, now with all this stuff here, okay, we need something that ties all of this together. And that's called the real numbers. I need to erase this. Is anybody taking notes on this or need to take a picture of this? I need to erase some of this.
I don't know why some people need notes on this shit.
Pardon me? Okay. It's on it. The video is there. You're being recorded, so okay. So we have rational and irrational. And what happens is we introduce something called real numbers. And the real numbers are a combination, are the rationals, irrationals. Remember, we talked about this U means combined with, all together. Remember when we did that for interval notation? We had that big capital U, the union symbol. Well, the real numbers is our math word for all of these combined with all of these. And the real numbers are everything on a number line. Anything you can find on a number line is a real number. It might be rational, it might be irrational. But the real numbers are anything you can find, 1, -1, 2, -2, and so on. Anything you can find on a number line is called a real number. Okay? Later I'll blow your minds on this. Now, some fun stuff. Fun with math. What about the square root of -2? Okay? If you have your calculator, try that. Okay? You have, where is it on this one? Ding, ding, there it is. On this calculator, it's second x squared. Find the x squared button, but right above the x squared button, it looks like that. So to get the one that's right above the x squared button, you push your second key, second that, and you get this symbol. Now to input -2, you have to use at the bottom of your keyboard here on your calculator. Now, different calculators are different. Oh, that's right. It's this screen. There's a little down here at the bottom. There's a little minus sign in parentheses. That's actually your negative button on this calculator. So if you want to input a -2, you have to do that. So I'm going to go second square root. First I'm going to turn it on. Clear it. Second square root -2. And then I'm going to hit enter. Whoops. And I got domain error. And I'll explain kind of what that means, but the key word here is error. I didn't make a mistake at all. Well, I did, but I got an error on my calculator. What that means is when you're doing the square root of a negative number, okay, it is not real. Okay, that's the correct answer, not real. That means it doesn't fit into either one of these categories, and it's not on the number line. So the square root of a negative number is technically not real, meaning it's not any one of these that we've spent the last 15 minutes talking about. Okay, not real. So keep that in mind. We're going to review this over and over and over again because, again, as we get higher and higher in the math, knowing this vocabulary, knowing all these sets of numbers, these groups of numbers, is important. You have to learn how to talk math. Okay, now I am done with chapter 1. Before I erase, does anybody have a question? Actually, I'm going to get you guys involved when we hit chapter 2. This is just sort of really boring. Sit down, shut up, and watch Foster talk. Okay. Any questions about integers, rationals, irrationals, not reals? Anything? Okay. Then, finally, we get to chapter 2. Okay. So finally, we're going to hit chapter 2, and we're going to talk about solving equations. Now, solving equations is a search for truth. And you guys may be laughing at me, okay, but you believe it or not. It's find the value of x that makes an equation true. Real simple example. 2x plus 1 equals 7. Now I know that most of you should be able to fumble your way through and get the answer. The answer is 3. Okay, but suppose I said, is 5 the solution? Okay, is 5 the solution? The way you go about it, you say 2 times 5 plus 1, does it equal, question mark, 7? 2 times 5 plus 1, that's 11. Does not equal 7. No. Okay, is -2 a solution? And then again, you play the game. 2 times negative 2 plus 1, does it equal question mark 7? Okay, solution question mark. 2 times negative 2 is negative 4 plus 1, that's negative 3. Does negative 3 equal 7? No. Okay, and we could do this all day long. This is the guess and check method. What's the solution to this thing? Okay, try numbers, plug them in, see if they make the problem true or not. Okay, let's say, is 3 a solution? Question mark. So we try it again, and we say 2 times 3 plus 1, does it equal question mark 7? 2 times 3 is 6 plus 1, does 7 equal 7? Yes. Now, let's be honest. This was stupid. Who in their right mind is going to spend all day guessing at what the solution is, plugging it in? I don't know, maybe it's this number. I don't know, maybe it's this number. Ah, man, you could waste your whole life. So, in order to speed this process up, math has invented a series of rules, an algorithm. An algorithm is a series of steps that you follow that get you the right answer. Math has invented an algorithm for solving what's called linear equations. Okay, so instead of guessing all day long, okay, we can go find the answer ourselves. And that's what we're going to do right now. We're going to talk about how to solve a linear equation. We're still searching for truth, but we're searching for truth in a much more organized way. Instead of plugging in values, okay, and saying, no, oh yes, 3 makes it true. Instead of guessing and guessing until we finally hit upon it, we're going to have a better way of doing it. Okay? Now, I'm going to put up some steps. You're going to want to copy these down at least into your notes for a while. I'll probably write them up again tomorrow. Okay? But here are the steps. First, we want to distribute to remove any parentheses. Parentheses we dislike because they stop us from getting into those numbers. First. Second, if there are any fractions or decimals, well, tonight I'm going to say skip this. Okay? We'll worry about these tomorrow night because it gets kind of tricky. Okay? So tonight we'll do this. Third, combine like terms on each side separately. And I'm going to explain all this, so don't panic. The one thing I will say, guys, I'm labeling these as first, second, third. There's going to be a fourth and a fifth and maybe even a sixth up here. It's super important that you follow these steps in the order that I've written them. Yes, sometimes there are shortcuts. Yes, sometimes there's a faster way to do a problem. But this way will always get you the correct answer. Always. Again, I confess there may be a faster way for certain problems. But this way will always work. So, first, distribute to remove parentheses. Second, fractions or decimals, we're not going to worry about it tonight. Third, combine like terms. I'll show you what that means. And he said separately. Fourth, use addition or subtraction Now I circled them so they'll stand out. Okay, you can write the words out. To, I'm going to say move, because there's no such thing in math as move, but I'm going to say it, and you'll agree with me in a minute when we do problems. All variables to one side of the equal sign, and all numbers to other side of the equal sign. Now I know my handwriting probably is terrible, so if you need me to rewrite it or to show you what I've written, I'll be happy to. Fourth step, use addition and subtraction to move all variables to one side of the equal sign and all numbers to the other side of the equal sign. And fifth, okay, use multiplication or division. That's a division symbol, not a sad face. Maybe it's both. To isolate x, the variable. And there will be a sixth, which I'll talk about in a minute. Okay. And I'm going to draw a line right between the third and the fourth step because our thinking changes here, and you'll see why. So let's take an example. 5 plus 2 parentheses 3x minus 1 equals 5 times 2x minus 4 plus 6. Holy crap. I mean, holy Jiminy Christmas. 5 plus 2 parentheses 3x plus 1 equals 5 parentheses 2x minus 4 close parentheses plus 6. All right, this is the worst case scenario. Almost all problems in MOM will be simpler than this, but I want to walk you through these steps. All right, first step, distribute to remove the parentheses. So that would look like this. 5 plus, distribute the 2 into here. 2 times 3 is 6x. 2 times 1 is minus 2. 5 plus, distribute, equals 10x minus 20 plus 6. So that would be step 1, if you're following what I've written up here. Distribute to remove any parentheses. Okay? There's no fractions or decimals yet. Thank God. Now, combine like terms. Third step. Remember, do these in order. Don't skip around. You skip around, you get the problem wrong. So, now I haven't talked about like terms yet. But on the left-hand side here, 5 plus 6x minus 2. What are the like terms? Anybody?
5 and 2.
The 5 and the 2, or the negative 2, but yeah. Those are just normal plain old numbers. So those you put together. 5 minus 2 is 3, so this becomes 6x plus 3. Combine like terms. Moving to the other side. What are the like terms here? Well, aren't they negative 10, 20 and 6? Add them together. Negative 20 and 6 is negative 14. So this becomes 10x minus 14. Okay? So that's the first three steps. We got rid of the parentheses. Okay? We thanked all the math gods in the universe. There's no fractions and decimals. And then we combined like terms. Like terms are numbers with numbers. If there'd been other x's, we'd combine them. But notice it says on each side separately. So in your mind, you're treating this equal sign, the left and right, as like two different problems for just a second. For just a second. Now, this is where the fun stuff. Almost everybody has heard the phrase, you got to do the same thing to both sides. Okay? Almost everybody has heard that phrase when it comes to algebra. Okay? You got to do the same thing to both sides. Well, that's where the fourth and the fifth step come in. For example, I want my x's to come together. I want them to be on one side of the equal sign instead of on two different sides. So I'm going to arbitrarily take away 6x from this side. Just take it away. But if I do that, okay, then I have to take away 6x from this side, because math is real big on balance. If you take something away from one side, you got to take the same amount away from the other side, because you're maintaining the balance of the equation. Okay? Well, 6x, take away 6x, those go away, and this just becomes 3. 6x, take away 6x is nothing. They go make 0, plus 3 is 3. Over here, 10x, take away 6x is 4x minus 14. What I've just done is I've used, in this case, subtraction to move my x's to one side. I took 6x away from both sides, and that made it appear as if all of my x's are now on the right-hand side. But I'm not done, because if you'll notice, my plain ordinary numbers, the 14 and the 3, are all over the place. So I have to get them to the other side of the equation. I have to add the same thing to both sides. Well, to do that, I want to get rid of a minus 14. I want to add 14 to both sides, because the only thing that will get rid of a minus 14 is a plus 14. Those cancel each other out. Minus 14 plus 14. But if I add 14 to this side, I have to add 14 to this side. Again, there's that balance. I want to get rid of a minus 14. The way to get rid of it mathematically is to add 14. But you have to keep everybody balanced. So if you say to yourself, I'm going to add 14 here, you're going to add 14 here. This gives you 17 equals 4x. The fourth step here is the hardest step. The fourth step is the hardest step because it requires multiple steps. It says keep using addition and subtraction. Only addition and subtraction. Until all of your x's are on one side of the equal sign and all of your ordinary numbers are on the other side. That's what it says. All of your x's are on one side, all of your other numbers are on the other side. Okay? Now, fifth step, use either multiplication or division to isolate the x. Okay, isolate means get x totally by itself. Question, who do you have to get rid of? If you want x to be totally by itself, to be isolated, you want to get rid of the 4. But what's the 4 doing to the x? When we say in algebra 4x, what does it actually mean? Anybody?
Multiplication.
Multiplication. That's implied multiplication. Okay? Well, what undoes or what cancels out multiplication? What's the opposite of multiplication? Division. So you divide this side by 4, and you divide this side by 4. What happens here, technically, 4 divided by 4 makes 1x. 4 divided by 4 makes 1x, but then we say 1 times x is just x. Most people just go, oh man, the 4's just cancel out. Yeah, they do, but mathematically they actually become 1. 4 divided by 4 is 1, and 1 times x is x. That's the math that happens. I need to explain it to you, but I don't care if you show it or not. All right, question. Does 17 over 4 reduce? It could turn into a mixed number. It could turn into a mixed number. You could say 17 over 4, or you could say that's 4 was 17, 4 times and 1 left over. Or you could use your calculator and call that 4.25. Okay? All of those are the correct answer. Okay? 17 over 4 doesn't reduce, so you can leave it. Which, if I'm being lazy, and that's one of my watchwords for you as a mathematician, if you were going to be lazy, which one of those answers is the laziest to write down?
4 1/4.
Nope, I disagree, but you might say that. This is an open-ended question. Look, if you already got 17 over 4, okay, you don't need to do any more work. It's totally possible that you make a mistake. If you wrote 4 1/4, okay, let's just say you made a silly mistake and for some reason your brain freezes up and you wrote 4 1/3. Now, I know what you meant. You know what you meant. The world knows what you meant, but you goofed up. You just kind of had a brain fart. Well, I got to take a point away, or a half a point, maybe. Okay? My point is unless the instructions tell you otherwise, 17 over 4 is perfect. You don't have to do any more steps on your calculator. Nothing more. I mean, this is correct, 4.25, but it meant you did an extra step on your calculator. And what if you have fat fingers like I do and you push the wrong button on your calculator? Then you're going to get a wrong answer. Even though it was a dumb, silly mistake, you got a wrong answer. So, in my opinion, okay, 17 over 4 is a perfectly legitimate answer. You'll get 100% credit. Okay? And you didn't have to do any extra step to get these answers. Okay? Now, having said all that, having preached all that kind of crud and whatever, I need to tell you to read the directions in Mom. Sometimes the directions will say, express your answer as a mixed number. Then you must do it this way. Sometimes the directions will say express your answer as a decimal. Sometimes the directions won't say, so you can pick. But pick the laziest correct answer. Okay? The least number of steps. All right. So, I don't have room. Oh, the one thing I want to talk about, the 6th step, and this is kind of awkward. The proper way to do the answer to an equation, the proper way, and I'm one of the few instructors at Mesa, or any place for that matter, that actually teach this, is to take the answer, okay, and put it in what's called a solution set. These funny braces. Okay? This is known as the solution set. If your great-grandparents, If anybody has great grandparents and they're still kind of all together up here talking, okay, and they learn this also as the truth set. Way back when they studied math back in the 30s, 40s, 50s, okay, this was called the truth set. What number makes the problem true? 17/4. It started off as being called the truth set, okay, and then we got fancier and we called it the solution set. And it should be in these funny braces. Now, Mom doesn't require them at all. But the teacher part of me says, I need to show you the right thing. And there will come a point in our course where you have to do this. So every time I do one of these problems, okay, I'm going to always end up with the solution set or the truth set. If you just want to circle your answer, cool. Okay, for now, that's cool. All right, I want to do another one of these problems, but I do have to erase the board to make room. Any questions about any of my steps? Any of my words here? Anything here that you want me to clarify a little bit more?
Just to clarify, so the sixth step is the solution set.
The solution set, yes. Thank you.
Thank you.
The sixth step is the solution set. Okay. And that's, again, that's just Foster and a couple of instructors. We're real big on that. The majority of the instructors aren't, to be really honest. Okay, but I don't mind being in the minority. I've been in the minority all my life. Question, can I erase the words here for everybody? I want to put another problem up. Can I erase these words?
Sure.
Okay. All right. I didn't hear anybody yelling. Okay. So we'll pause in just a second. Another example. 2x plus 4 times 3x minus 2 equals, I don't know, 5 plus 3x. That'll be good. Okay, so I'm going to pause the video and let you guys work on that. All right, so first step, distribute to remove parentheses. So on this side, we distribute the 4 in. So this is 2x plus 12x minus 8. Oh, you're right, it is 11. Equals, now there's no parentheses on this side. So I just bring it down, 5 plus 3x. Okay, quick, erase my mistake. Okay, no fractions, no decimals. Those will happen tomorrow night. That'll take a good amount of time. They get messy. So the third step was on each side separately. So thinking of this as two separate problems, combine like terms. Well, on the left-hand side, we have 2x's and 12x's, so we have 14x's. For like terms, they have to have the same variable, then you just add their numbers. 12 and 2 is 14 of the x's, minus 8. Equals, okay, nobody can add together. You can't add a 5 and a 3x. They're different animals. They're not like terms. All right, so this is after step 3, where I combined like terms, distributed, and then combined like terms. I'm down to here. Okay, now is when I want to go to step 4, when I start moving stuff from one side to the other side. And I'll be honest, there are shortcuts, but I want to make sure that we all get the right answer. So I am just simply going to go for my x's. Eeny, meeny, miny, mo, this x is going to go. Doesn't matter. I'm going to get rid of a plus 3x. I want to move it. So what gets rid of a plus 3x? Well, how about a minus 3x? Okay, but if I subtract 3x from that side, for balance, I have to subtract 3x from the other side. Solving an equation is always about balance. It's getting rid of something. I want to get rid of the 3x, but I have to keep it balanced. So 14x take away 3x is 11x, take away 8 equals 5, because the 3x's here just dumped out. Okay, now I got all my x's on the left-hand side. I want to move all my numbers to the right-hand side, which means I want to move this minus 8. I want to get rid of it. So what gets rid of a minus 8? A plus 8. Okay, so this is 11x equals 13. 8 and 5 is 13. All right, so this was all step 4. Using only addition and subtraction, move all of your variables to one side of the equal and all of your normal numbers to the other side of the equal sign. And notice my eeny, meeny, miny, mo, it doesn't matter what side you move them to. It doesn't matter. Just move them to one side and move the numbers to the other. All right, now we want to get x alone. So in order to do that, we want to get rid of the 11. But once again, the 11 is implied to be multiplying. So you're going to divide, because multiplication and division cancel each other out. But if you divide the left side by 11, you've got to divide the right side by 11. That balance kicks back in. Keep it balanced. Technically, this makes 1x, but nobody cares about that. They just say x equals, okay? And I would say this is 13 over 11, okay? Foster personally would go solution set 13 over 11, okay? Those are those funny braces kind of thing, okay? But if you just did that, I'd be delighted. Questions on that? None?
I have a question.
Sure.
So would it be okay if I put inside the brackets x equals 13 over 11?
No. Okay, and it's a technical reason. The solution set is just the number. Just the number. See, x is totally unimportant. You don't have to use x. You could have used q. You could have used r. The variable that we use is unimportant. Okay, it's just the number value that's important. So the solution set or the truth set is only the number. Now, if you did that, I would scribble it off, write you a little message, and I wouldn't do anything to you at all. I wouldn't take points away. Don't sweat it. Does that answer your question?
Yes, it does.
Okay. Anybody else? Okay. Tomorrow night, now hang on, I'm going to take roll again in a different way, so hang on. Tomorrow night, we're going to continue with this solving equations, but we're going to include fractions and decimals, which I ignored tonight. Okay? And we're going to talk about inequalities, less thans and greater thans. And if we have time, we'll talk about absolute value. We got a lot tomorrow night, a ton. So please make sure you're here. Remember, all this week we're Zooming. All next week we're Zooming. Okay, all this week we're Zooming. All next week we're Zooming. Okay, so what I want you to do tonight is I want you to email me again tonight. Email me lafoster@sdccd.edu. Okay. In the subject line, okay, again, your real name, okay, not whatever it says on your email, which some of you have some really weird emails. And either on the subject line or inside the body, I want the answer and only the answer, okay, to this problem. Don't write the problem down. Give me the answer. That's it. Good night. See you guys later.
Thank you. Goodbye.
Goodbye. See you.
Bye. Thank you.
Uh-huh.
Professor, we have to send you an email for the answer?
Yeah. Just like last night you sent me the magic code word. Tonight you just send me the answer, whatever that is. So on your, you work it out.
All right.
That's it. That's all you got to do.
Cool. Thank you, Professor.
Yep.
Oh, I
See you.
forgot yesterday. I didn't know how to send the email. Hopefully it doesn't count against me.
Well, that's the email address that I've been sending all summer long.
Yeah.
Oh.
No, like I forgot to send the email like for the roll yesterday.
Yeah, it did count against you.
Oh crap.
But yeah, I mean, otherwise, that's how I take a roll sometimes. Now, tomorrow night, I'm going to do something totally different.
Yeah, because I was actually present, but
Okay, got to follow through on these things. One night is just not that big a deal. Don't worry about it.
okay. Get this.
Huh. Stop share.